I want us to end this session with a little bit of a challenge. In order to complete the challenge, you'll have to learn one more new skill. Here's what I propose. I want you to make a machine that reads in a certain value of light and then uses it to make a gauge. As in, if there's more light, the thing will turn more to the right, and if there's left light, or clockwise, and if there's left light, it'll turn more counterclockwise. You have everything you need to do this in terms of hardware. There's one more little software thing you'll need to learn to be able to complete this. But let's just start to tackle this from a simple design perspective. If I need, this is an input and that's an output. So that input is a photoresistor for us. There's other ways to measure light. There are devices which are dedicated to measuring light, but we don't have any of those. Sorry about the video. I'll get it back in a moment. We don't have any of those devices. Sometimes if you want a very high precision way of measuring something, you do need to, or you are able to, buy a fancier piece of hardware that has that specialty. But so let's say pin A3, we'll do this exactly as we did it before. Like that, up to 5 volts. And then we have on this side our resistor down to ground. This is a 5.1K resistor. Okay, we know how to build all that. And that is the totality of the wiring needed for this part. What is the totality of the wiring needed for this? Well, if you want to point something in a certain direction that can change its angle, probably a good idea is to use a servo motor. So I'll just draw myself a servo motor. That needs power, and we can get that from the 5-volt supply. It needs to be grounded. We'll attach it to that ground, and it will have a signal coming in from it, into it, and maybe that'll come from pin 6. Okay, well, the wiring is complete. We would have to just build this thing in physical real life, but that's going to be your input, that's going to be your output, and all that's left is the stuff in the middle, the firmware, the software that's running on the Arduino. So how would you actually do this? Well, the way I would actually do it is I made a new sketch over here on the left. I called it light to servo, and I am holding up 2 other sketches, and I know I'm in the way of one. I'll trade their positions. To the right of it, I've got read a photoresistor and basic servo. So I'm actually going to just mush these things together. And this is an actual tactic you will actually find yourself doing. So I'm going to start by copying. In this case, I can copy all of the read a photoresistor value, and I'm just doing a copy paste operation here. Because I need all this stuff in order to be able to read the photoresistor's value. And so again, this sketch is the read a light value, turn it into a motor position sketch. I'll trade these positions so then we can start copying in the necessary things from the servo sketch. Now, if we just copy paste them both, like both entire sketches, we'd have 2 setups and 2 loops and it wouldn't work. So we have to be careful about this. So include servo.h. Yeah, we need that. So I'll put that up top. We should make the servo object. Oops. That's going to be, I'll just use this so you can see exactly what's happening. All right. Now here I've got my const int photo pin. I'll also copy over my const int door pin. So I've got my pins in the same place, and that's nice to keep them all lined up with each other. Now I'm in the setup of my new sketch, and what do we need from here? We need the door motor dot attach. I'll put that here because I want, oh, and so I've got some like formatting silliness. It's like improperly indented. I'm going to go to Tools, Auto Format. That's easy and quick, and it fixes all your indentation problems. And now I'm going to copy just this door motor dot write, the number 17. Copy that, and I'll put that down here in our loop. And I'm going to make this thing finally wider. So we're just going to focus on our output sketch. So I'll just, for the moment, put this like here. Now we have here, I'm going to save it. From the top down, we have the thing, we needed this for the servo library. and we needed this. It's not a door motor anymore, it's a gauge motor now, or a dial, I'll say gauge. So instead of calling it door motor pin, maybe I'll call it gauge motor pin. And by the way, renaming variables for like their appropriate exact purposes is a really good idea. You don't want to leave old stuff kicking around in your code that's no longer relevant or no longer useful to what you're trying to do. So it is worth the time to fix this kind of stuff. And instead of door motor.attach, gauge motor.attach. Down here, instead of door motor.write, gauge motor. Okay. The photo pin, of course, I didn't have to change anything because it's just the same. So what do we actually need to do to actually hook the two up? Well, instead of doing gauge motor.write and then the number 17, maybe we should do gauge motor.write, like actually tell it where to go based on the photo val. So you might think, okay, well, I'll just put the photo val in there. We're done. You're not done. There's a problem. And I'm just going to close these other sketches so it's a little cleaner. There's a problem here. The problem is, in this line, gauge motor.write photo val, you're going to think of the values that photo val might be. That is an analog read. So the minimum analog read is 0. That's fine. We can do a gauge motor.write 0, no problem. The maximum analog read is 1023. We can't tell the motor to go to the position 1023. We're going to probably physically harm the motor because we're going to be telling it to physically move past its own end limit, which will actually literally harm it. So there's a problem that needs solving. So I'm going to just put some question marks in there. By the way, do we need the serial print of the photo val? Not necessarily. It doesn't really hurt to leave it in there. But so maybe you can plug it into the computer and see what's going on, like why isn't this working? It's really useful to have those serial print functions around, but it's not necessary for this. We are going to need to solve this problem though. And in order to do that, I'm going to introduce a new function, and we're actually going to learn about it on paper first because I think it's worth sketching out what it does. The problem we have is we need to turn one numerical range into another. There is a function that will do exactly this. Here's how the function is going to work. First, I'll describe the inner workings, or not even, but the behavior of it straightforwardly, just to be clear on what it does. Imagine this were degrees Celsius and this were degrees Fahrenheit. So if I label, and this is just a single scale, so you can think of this as simply a thermometer. It's got markings on it. At the bottom, it says 0 degrees Celsius, and at the top up here, it goes to 100, because this particular thermometer goes from freezing to boiling. Fine. What is the equivalent of 0 degrees Celsius in Fahrenheit? It's 32. Water freezes at 32 Fahrenheit. What is the equivalent of 100 degrees Celsius in Fahrenheit? Water boils at 212 degrees Fahrenheit. Once you know the endpoints of one scale and can match them with the endpoints of another scale, then you are able to say something like, well, what is like 37? And by doing some mathematics, you could figure out that if this is 37% of the way between here and here, then you could just say, okay, what is 37% of the way between 32 and 212? And the answer would be like 98 or something like that. Whatever, ballpark. So by having the 4 endpoints, we can compute this. There's a function called map, and that function will do this for us. In this case, if our question mark output were the number 98, then here's how we would write the map function. Our input value is the first thing we write, which would be 37. The next 2 things we write are the range of the input value, which in this case would be 0, 100. Then the last 2 things we'd write would be the output range, which would be 32 to 212. All of these things are separated by commas, and that is the totality of the map function. What this will do, this whole thing, this big long thing, will return the number 98. Why is this relevant to us? Well, we have a different range we need to negotiate. We have an input range between 0 and 1023. We have an output range between 0 and 180. These are analog read values from your potentiometer, I'm sorry, from your photoresistor. And these are degrees of rotation. We want to be able to say for any given analog read, this is where I want you to turn the motor to. So, and I'm running low on space, you're going to write a function that has some input variable, and it's going to output a result. So, just to go back into the software, what will the map function actually look like? Well, you'll type the word map, and then you could put some parentheses, and then we'll put all the stuff inside that we need. The first thing is I'm just going to call it the input variable. I'm leaving those English words for now, and then we're gonna drop something in instead. Comma. The minimum of the input range is 0. The maximum of the input range is 1023. The minimum of the output range is 0. And the maximum of the output range is 180. Now, what if you don't want the thing to go all the way from 0 to 180? What if you want it to go from 10 degrees to 170? Well, that's an easy adjustment. We can just do that. In fact, I actually recommend it because the servo motor doesn't actually do great going all the way to the ends of its ranges. I find the inexpensive little cheapo servos that we have don't always necessarily do that well. So now what is the input variable? In our case, it will be photo val. And you can run this entire line of code and it will work, but we have to save the result. This is just like doing an analog read. We have to save the result into a variable. So I recommend making a new variable called motor pause, and you can start it by equaling 0. It doesn't really matter, because in this very next line, we'll say motor pause equals map, and there you go. So we're going to gauge motor.write what? Well, I'll leave that as an exercise to the reader. I hope that will be fairly straightforward. If you complete and run this code and complete and build the circuit, you should actually get that gauge behavior. Now, what if you don't like the gauge behavior? What if you discover that the input values don't actually get down to 0 and don't actually get up to 1023? Well, I encourage you to experimentally see where those values actually get, and then adjust the ends of your map function so that it actually does behave as a reasonable gauge. And then you can, turn the light off in the room and the gauge should turn all the way one way. Turn the light on and it should turn all the way to the other, etc. So this is a fun exercise. It's the first time we're actually mushing things together in this way and using the Arduino as intelligent glue. I encourage you to build it and see if you can actually get it working.